Welcome to Build 2021. This is the session CI/CD with Snowflake using Terraform, GitHub Actions, and Schemachange. We got a lot of good stuff in store for you. I'm Jeremiah Hansen, Principal Data Platform Architect with Snowflake. And I've got Allison Doami with me, Software Engineer from ZUCKERBERG Initiative. And we're super excited for this session today. Just to run through the agenda, we'll briefly introduce ourselves, Allison and I, and then I'll go through and talk about the database change management tool landscape and give you an overview of what tools are out there and how they work. After that, I'll review some of the popular patterns that we see customers using when it comes to doing database change management. And then probably the best part of this session is going through and doing two demos. So we'll have a demo with Terraform that Allison will take us through. And then I'll go through and show Schemachange and how that works in conjunction with Terraform. So you'll be able to see both tools working together in a real demo. And then we'll wrap up with a few next steps. So for introduction, I mentioned my name is Jeremiah Hansen. I've been with Snowflake for 2 years now. My background's all in the data engineering space. So I've worked in all the various roles as a data engineer, an architect, dev manager. I worked for Slalom Consulting for 9 years, and then now at Snowflake. And my focus of my career has really been around data engineering and figuring out how to apply software development best practices and DevOps to the data engineering space. And Allison, I'll let you introduce yourself.
Yeah, I don't have as much experience as Jeremiah. This is actually my second year out of college, and the ZUCKERBERG Initiative, or CZI, is my first job out of college, but it has been such a pleasure to learn what it's like to be on a data infrastructure team. And we use Snowflake every day at CZI. So it's been very rewarding to be able to give back to the community by reviewing a lot of pull requests to the Terraform provider for Snowflake. And hopefully I can teach you a little bit about how to use that and how to make your pipeline a little bit better and easier to use. And if you don't know what the ZUCKERBERG Initiative is, it was actually founded in 2015, so we are still relatively new. We have 3 initiatives which are solving today's toughest challenges. 3 of them are education, science, and community.
All right, so before we jump into the demos, though, I want to take a second to go through and discuss the tools that are out there, because this is an important thing that I get asked all the time about. And what I'm going to go through is a very abbreviated version of the recording that we have available on developers.snowflake.com/resources. The title is the DevOps Recommendations when Building on Snowflake. So feel free to go there and check out the full version of this. I like to start by taking a step back, though, and looking at kind of the whole task that a developer has to go through. When you think about building a data engineering pipeline, there's a bunch of pieces that are involved. And when people ask about doing DevOps with Snowflake, they generally are referring to database change management, which you can see there kind of at the top left. And that's about how we manage our database objects in code and deploy them through an automated process. But when it comes to like the end-to-end, there's a bunch of things to think about. And I like to put this up to kind of give the context. So at the bottom, this is supposed to represent a football playbook. And you can see at the center there is the quarterback, the software automation tools. I think it's helpful to think about these as essentially orchestration tools for software development. That's what they're doing, is coordinating and orchestrating different activities like a quarterback would do. And so there's various tools today. We're going to see GitHub Actions in action. But if you look at what you have to do, there's a bunch of other things that are included and involved in a DevOps pipeline. If our goal at the end of the day is to produce tables of data, then we need to not only create the tables, but populate the tables. And so there's a bunch of steps that go into it. And you might have everything from cloud resources to your database objects to the process that you use, whether that's an ETL tool, replication tool, or a custom process. So all of that has to be coordinated through one of these CI/CD tools. And then of course we need Git. In order for this to work, everything has to be defined in source control, in files, so that we can manage it and version it and do all of the things that we need to do. And so that's the kind of quick overview. And what we'll focus on now is the database change management side in particular. So the task of database change management is to take all of our objects in Snowflake and to manage them in code and through a development lifecycle. And as you can see from this, we have different types of objects. So there's account level objects and schema level objects. And those schema level objects are the ones that are inside of a database schema. And as you'll see when we get to the patterns, we need to figure out for each of these objects, which tools are going to manage them. So one thing that's really important as we talk about the tools is to briefly discuss the types of tools, because they work very differently. And you're actually going to see both of these in action. But an imperative style tool, the way it works is that you create version scripts that you manage in source control. And those version scripts, the content of those scripts, you manage entirely yourself. So imagine we created a table, foo, and initially the table had 2 columns in it. So the first thing we're going to do is create a script that's version 1 that has the create table statement. And this is a simplified example. You'd often have other statements in here as well. And then a month later, if we decide we want to change the table, we don't go back and change the first script, the version 1. We create a new script, version 2. And in that script, we would write the SQL commands that we need to transform the database. So in this case, an alter table statement. This is why it's imperative, is that we're the developer is telling the database how to transition, what changes to make. And so the tools for this, the imperative style tools, they have to keep track of the versions. So for every environment, whether that's dev, test, or prod, or whatever your environments that you have, the tool needs to keep track of versions. And then as you deploy to each environment, it needs to compare what's in source control to the version, to the environment, and decide which scripts need to run. So the tools are pretty simple. They're just running scripts in the right order and making sure they run one time. Now the declarative style is different. So in code, you're actually managing a single file per object. In this case, you would have a file for the table foo. And when you make changes, you actually go back to that same file and update it. So imagine that initially table foo had 2 columns in it. Well, this file would only have those 2 columns initially. And then a month later, when you changed it, you would actually go back to this file and you would edit it and add the 3rd column. So a different kind of approach. And the challenge now is the tools for declarative have to be much smarter. So they have to actually be able to go out and compare your target environment with your source control and figure out what needs to happen and generate those alter statements for you. So you're not writing the alter statements with these tools, they're doing it on your behalf. And so the tools, like I said, have to be much smarter. And as we'll see, I'll go through the tools in a second here, but the imperative style is like Schemachange and the declarative style is like Terraform. Although in Terraform, it's not going to be SQL based. You'll see as Allison goes through that example. So that's the 2 styles. And the reason this is important is that most of the tools that are available are imperative. And that means that we talked about briefly how they work. The most popular ones with Snowflake are Flyway and Schemachange. And then there's other tools. My brief summary is that if you have one of these tools that you're using today, then by all means, continue using it. They work with Snowflake. They're all great. If you're starting from scratch, you don't have a tool, then Flyway or Schemachange are good ones to start with. And in the fuller version of this, I talk more about each of the tools. For declarative, there are 2 options, Terraform being really the most mature. And the one caveat with Terraform and we'll actually show this in the patterns, is just to know sort of where it fits in the scheme of things. It supports most objects. There's a few that aren't yet supported that I'm sure will be added over time. But the key thing to point out is when it comes to tables, I don't recommend you use Terraform to manage your tables, because the way it works today, the provider, is every time you make a change to a table, it drops and recreates it. And as you imagine, for a data environment, that's usually a bad thing because you have history that you need to preserve. So, and this may change, but for now, the recommendation is to not use Terraform for tables. And so I'll show you in the next section on the patterns how this fits and where customers are using Terraform and the imperative style tools. And then I'll save the discussion on dbt for the recording, maybe to entice you to go watch it. But we can talk about there how dbt fits into as a declarative tool in part, not entirely. So the last section here is just around talking through the patterns. And these are patterns that we see in the real world that customers are using. And there's really 4 of them. I'm going to focus on number 3 today. And then the variations, again, will be saved for the full recording. So the nice thing about imperative tools is because you write the code, you can do anything you want. They support any object that's there, as long as you can write the SQL to do it. And so you can use a single imperative tool like Flyway or Schemachange for all of your objects. So that's a simple option to start with. And if you're not using Terraform today and you're just starting from scratch, this might be a good place to start. And then if you are using tools like dbt or replication tools, this is a pattern that's pretty common, is to use those tools for the objects that they manage for you, which are the tables and the views and a lot of the code that you would put in stored procedures. And then use your imperative style tool to manage the rest of the objects. That's a pattern with if you're using dbt. Now, the real one for today that we want to focus on is option 3, which is Terraform plus an imperative tool. So the way that most customers are doing this that seems to work really well is to use Terraform to manage all of the, I call this infrastructure-like objects, but all the objects that are related to setting up an environment. And that's generally the account level objects plus a few of the things that go inside of the schemas. And really, it's the things like stages and pipes that connect to cloud resources. And that's the power of Terraform, is you can manage those cloud resources and those objects in Snowflake and all the dependencies between them. So that's a great use for Terraform to get those environments stood up, whether that's provisioning, a dev test environment, or even provisioning environments for other teams. All of that can be managed and done through Terraform. And then you might choose to take an imperative style tool like Flyway or Schemachange to manage the objects inside of that schema, inside of those schemas that have been populated. So that's probably the most common pattern then with Terraform and one of these tools. And the fourth is if you have DBT as well, that you would use Terraform in the same role. So Terraform could provision and set up those environments, and then DBT replication tools to manage objects that they manage, tables and views in a lot of the stored procedure code, and then an imperative tool for the other objects. So as you can see, it starts to get a little complicated in this kind of option where you have 3 different tools. The reality today is there isn't a single tool that does everything. So except for the imperative style tools, which was option 1. So you will end up most likely using a couple tools to manage everything correctly. And then in the full recording, we talked to you about how you might choose to manage users, roles, and grants in a slightly different way. All right, so with that, we'll get into the demos. And we'll start with Allison walking us through the first part of option 3 here, where we're creating objects with Terraform.
Hi everyone. So Jeremiah created a fantastic quick start guide called DevOps Database Change Management with Terraform in GitHub, which you can find on the Snowflake Quick Starts website, which goes over how you can manage your Terraform through GitHub Actions. If you've ever wondered what the Actions tab is in your repo, which is right here, that is GitHub Actions. So GA is a great CI/CD tool. CI/CD stands for Continuous Integration, Continuous Development, which is built right into GitHub. All repos have the ability to utilize GitHub Actions. You just need to set up a workflow. One huge benefit of using a CI/CD tool for managing your Terraform is the ability for your entire team to write Terraform code without having to use a command line tool and manually apply changes. Before we set up a CI/CD tool at CZI, we would manually apply our changes, which can be really dangerous since it wouldn't require code review. Using something like GitHub Actions allows you to easily manage and apply your code. So I won't spoil the whole tutorial for you, since it is quite fun to do on your own, but I'll quickly go over how to navigate Terraform Cloud, how GitHub Actions works with Terraform to apply your changes, and some tips and tricks on Terraform etiquette. So in Terraform Cloud, on the home page, you'll be able to see the organization that you created at the top left. I called mine Snowflake Build 2021. You'll see the workspaces that you created for this organization. So for me, I just named it some generic names for this demo called Workspace 1 and Workspace 2. And basically, workspaces in Terraform Cloud terms are environments for a collection of infrastructure. They can store variables, state files, credentials, and secrets. And I'll show you quickly how this aligns with the file system that I set up in my GitHub repo. So in a real life scenario, you can organize these by your various Snowflake accounts, for example. So instead of Workspace 1 or Workspace 2, you can name them after your team name or whatever your accounts are called. So you'll need to create a new workspace for each of these environments you want to have. So if I wanted to make one for our education team, then I can call this workspace the education team, whatever the Snowflake account is for our education team. And then I would put in the corresponding workspace that I named back over here. So I'd also have to name this the education team's Snowflake account. I also want to briefly explain why I organize my workspaces this way. In the demo, in the docs, it instructs you to create a main.tf file to put everything, including the provider, the workspace name, and all of your resources. This is great if you just have a few resources that you want to manage, but if you end up having a lot more resources and you want to organize it a little bit more carefully, I put the provider in a separate file, databases in a separate file, schemas in a separate file. If you have tables, you can put that in a separate file. If you have grants, role grants, schema grants, anything that you want to manage in Terraform, then you can make those separate files and replicate that in each of the workspaces you have so that everything is put in its place. So going back to the Terraform Cloud UI, we're going to hop into one of the workspaces and I'll briefly explain what all these tabs are. So the runs here are all of the applies or plans that you make in this workspace. So you can see who has triggered an apply. So you can see I did from the CLI, which is meaning from GitHub where my PR is. I see that it successfully applied. I can see the ones that didn't successfully apply. And in the states, you can actually see what has changed in between each of your PRs, which is pretty neat. So this should be your source of truth because you can see explicitly what exists and what does not. And for variables, since we're using our Snowflake provider, you're going to need some credentials in order to make changes in your Snowflake account, and you would provide them here. So we have the Snowflake account, Snowflake user, Snowflake password, and the Snowflake role, which has to be account admin or something similar. And now it's time to set up our code in GitHub Actions. So in the quick start, there's a simple workflow and a more advanced workflow. I highly recommend trying out the advanced workflow because there are some pretty useful features in there. So because I have different workspaces, I need to let GitHub Actions know where to find each of the Terraform configurations that exist for them. And in order to do that, I use GitHub Actions matrix attribute, which is analogous to an array, which is right here. And under jobs, I can specify which directories to run my steps in, which I put here. So since each workspace may include a different Snowflake account or a different configuration, they'll need separate applies. So we need to specify which workspace we want to run a Terraform init, which is here, Terraform init, Terraform plan, and then apply at the end. So my PR that I have created, GitHub Actions will read that a PR has opened, so I'm going to run the jobs that are listed in the workflow that we created. And so I've made some changes that I want to apply in my repo, and every time I push to my repo and I open a new PR, GitHub Actions runs those steps and actually posts a plan of my changes right in the PR, which is very convenient. So for my first workspace, or my second workspace, it looks like went first, I am deleting one of my schemas, and in the other workspace, I am creating a schema, which is pretty neat, and it says that they were both run successfully. You can see that they're two separate workflows. So once I merge my PR, I can go back. I'm going to merge this. I'm going to go back. You can go to the actions page, and you're going to see that I just merged my PR and that two jobs are about to run. You can also see things going on here. Once that job is kicked off, you'll be able to see them start to run. But you can click in farther and see that it's going to apply. Cool. And you can see this lock next to each workspace, which means that this Terraform account is in charge of this state right now, so no one else can touch it, which controls the state at the time, which is good because you don't want multiple people trying to change the state at the same time. So it looks like it's applying. So for my workspace, I have, it looks like manual apply turned on even though it auto applied my changes, but I found that at the end of our workflow, it says Terraform apply auto approve. So if you include this auto approve and you have manual apply turned on, then it will automatically apply your changes. So if you don't want to automatically merge those changes or apply those changes, then remove this flag in that last step of our workflow and make sure that manual apply is on, and Terraform will ask you if you want to apply or not. And yeah, so it looks like that successfully worked, and workspace 2 also worked. I can see the run was ran successfully. The state is different. You can see that what has changed is I deleted a schema here. So that's about it. That's the entire workflow, and I hope you make use of all these useful tools and maybe make your life a little bit easier. Thanks.
All right. Well, thank you, Allison, for taking us through the Terraform Quick Start. This second demo, I'm going to take us through the Schemachange Quick Start. So just to refresh, we have a pattern here which is very common for Terraform, which is to use Terraform to establish and create all of the infrastructure like objects, the environment, and then we'll use an imperative tool like Schemachange or Flyway or other to manage the objects within the schema, and particularly the tables. So that's what we're going to run through. And I'm going to show now, Allison walked us through the Terraform part, and this will complete the story by showing the Schemachange part. So we'll get out of this, and we'll actually start here with the Snowflake quick starts. So like we did before, down here we have a quick start that's around, this one in particular is for database change management with Schemachange and GitHub. And again, this has the step-by-step details that you need to go through and get this working. The demo I'm going to show is going to be slightly different in that it takes a different pipeline. It actually integrates the two things together. And we'll come and look back at this in just a second and pull some of the changes out. So this is what after the session, you can go through and follow this step by step. All right. So Schemachange is available, like I mentioned, it's an open source tool that's not an official Snowflake product. It's hosted in the Snowflake Labs organization, and you can see it here at Schemachange. So a bunch of great documentation. I will just quickly go down to the versioned script naming and explain kind of how this works so that when we actually look at it, it makes sense. So the way that Schemachange and Flyway work, and again, this is called out here, but this is actually the naming convention that Flyway has created, is to use the letter V as the start of the script to tell what type of script it is. In this case, it's a version change. The next part is actual version number, and this can be any pattern you come up with as long as you're consistent. I would recommend using a 3-part number with periods, so something like 1.1.1. Then you have a separator, which is 2 underscores. That's really important. And then after the 2 underscores is a description that's arbitrary. You can put whatever you want in there to describe what this change does. So that's our versions script. There's other types of scripts like repeatable migrations that are in here as well, and then other documentation for getting started. So that helps you get started with the Schemachange naming. So let's actually go out, and I'm going to go back to the guide really quick. Let's create a migration. So this guide has 2 different migrations in it. For this demo, I'm just going to show one. And in this case, we'll create a script with this exact name from the guide. And I've got it set up here in Visual Studio Code. I've got a repository in GitHub, and I've got everything already set up. So I'm going to come into the migrations folder. I'm going to add my new script. I'm going to give it the exact name from the guide. And then as far as contents, I'm going to take the contents from the guide, but I'm going to make one small change to it. So if you remember in the previous demo, Allison used Terraform to create the database and the schema. And so in this case, we're going to change, and we named the schema demo schema. So we've got now, we'll just use the one that's already there, and then we're going to create a new table called Hello World with 2 columns. So that's our initial change. And I've already got the pipeline set up, which I'll show you shortly. But what I'm going to do now is go ahead and commit this change. So initial objects. So I give it a comment, check it in, and I'm going to push that to my repository. So that will actually trigger the pipeline. And so let me flip back to the guide. So we did a little bit of setup, and I'll walk you through that just in a second. The GitHub Actions workflow, as you remember from the previous demo, is based on in YAML. And so this is the example that you can copy and paste where it will go through and deploy the objects. The one I've created, like I mentioned, is slightly different. So if we flip out to look at it here, I've actually incorporated in this one both the Terraform and the Schemachange. So I just put the 2 together, which you can do the same. So it goes through and does the Terraform steps first, and then at the bottom, it does the schema changes. So it installs Schemachange with pip install, and then runs it down here. And you'll see that all the settings that I'm passing to it are all defined here in these secrets. And this is in GitHub, the way to manage these arguments. So under settings, so in my project here under settings, down under secrets, I've defined all of these. And I've also got my Terraform token as well. So that's all of my secrets that you can see how they get used in the pipeline. So I've got that all set up, and I have it set up that it will trigger. So it's actually already run. You can see that we have our initial objects here. And if I look at the pipeline, so again, this is the run of the pipeline, and I can actually go in and look at the specific job, and I can see all the steps. So this is great for debugging. I have the Terraform steps, and as you would imagine, we don't have anything to deploy here. There's no changes. So the database and the schema already exist. So there's nothing for Terraform to do. And then for Schemachange, we did the install and the deploy. And if I scroll down to the deploy logs, you'll see that it ran it with all the arguments. GitHub Actions will hide those credentials or those things from you, those secrets, but it shows you which change history table you used. And then you can see that we applied one change script. So it ran version 1.1.1 with my code. So that ran successfully. This is showing, this example here is putting these both into the same pipeline. This could definitely be split up. And if you have different teams managing the different aspects here, one team or one workflow could handle deploying the Terraform objects and getting the environment set up, and you could have Schemachange separate. So this can be done a couple different ways, but here's a simple example with them working together. All right, so now that everything's run, we should just go over to Snowflake and take a look. So you have to trust me that this object didn't exist before. I drop them before I run this. If I refresh this now, you can see that I have the hello world table with my 2 columns. And then I want to point out specifically how this works. I mentioned this in Schemachange, it has to keep track of the versions, and it does that with this change history table. So this is a table that Schemachange in the instructions describes how to get set up. But you can see here that I've got one record in it, and it's the script that I just ran. And you can see the script version and name and all of that. So this is the way that Schemachange keeps track. So it knows, and they have a version of this table, an instance of this table for each environment. So Schemachange knows for each environment what the maximum version is, and then it can compare and apply the scripts that need to be run still. So that's really the way that how it keeps track of the state. And then we can also go look at the history. One thing that's great about Snowflake is that you can see all the entire query history. We can actually see the table getting created. So here's my create table statement. Hello world. And the other thing about this is just a Schemachange specific thing is we use the query tag capability so that every query that runs from Schemachange is tagged. And then specifically the queries that run from the script that you've created will also be identified with the script name. So we've got the way for you to tie back these changes to your specific changes that have been deployed. So that's really the quick version of the guide. Again, it will run through and goes through 2 different changes and how to run those, but since I had it created already, this is a simpler way to do it. But please feel free to go out to the guides, follow through. We have the 2 different guides here. Just going back to this, they're the ones in green. So we had the one that was Terraform in GitHub, which I also went through. And then we have Schemachange in GitHub, which I just showed you, did a brief overview of. So with that, you should be good to go, and good luck. All right, well, we have a few next steps to discuss. A couple of things to check out. So I mentioned earlier the developers.snowflake.com site. This is a great place to go for all of the resources that are available for developers building on Snowflake. The quick starts that Allison and I walked through are available at quickstarts.snowflake.com. And in particular, you want to check out the 2 that I have listed there. So it's the Terraform in GitHub, and it's the Schemachange in GitHub. And then we also have a bunch of code like the Schemachange project and others that are available at github.com/snowflakelabs. So you can check that out. And then I wanted to point out one of the things, Snowflake is, in my opinion, the best platform for doing DevOps, best data platform for DevOps. And this ebook really explains why. The task of doing DevOps for data platforms is challenging, but Snowflake really does simplify it in a unique way. And so this ebook walks through 10 ways in which Snowflake makes the process, simplifies the task. Doesn't take away any of the challenges or all the challenges, but it does simplify it dramatically. So this is a great resource as well. And then finally, just a reminder that the full presentation can be viewed on developers.snowflake.com/resources. And you can get the stuff that I left out and some additional things. So with that, thank you for your time. Thank you, Allison, for helping out.
Yay, glad to be back. Thank you so much.
Right. Take care, everybody.